We begin by putting our Wi-Fi adapter in monitor mode. I hit iwconfig on the terminal to list my wireless interfaces. I notice WLAN 1 and WLAN 0 both in managed mode. WLAN 1 is my external Wi-Fi adapter and WLAN 0 is my internal Wi-Fi card. We'll be putting them into monitor mode. I begin by airmon check kill, which kills any interfering processes, and then start WLAN 0 and start WLAN 1. On hitting iwconfig again, we see both of the interfaces have turned into monitor mode. 090 mon here is just the monitor mode virtual interface for 090. I can hit airmon with a specific interface again to now cycle through nearby wireless network channels, and I see the basis IDs of the nearby routers listed here, along with the channels, the encryption, and the ESS ID, which is the common name. The below table shows me devices which are connected to a specific router on a specific channel. We'll be using this shortly. We now capture the handshake between the client and the access point. It is recorded by the WPA2 encryption protocol. Using the aerodump ng command and specifying the BSS ID and the channel, we write to a capture file using a specific interface. On doing this, the BSS ID of the router you selected will show up, and now we are waiting for a device to show up which is connected to the specific router. Now that the device has shown up, we can see the station is communicating on. We can use this to run a Deauth attack using the airplay ng command and to send 10 Deauth packets to the device. Device on the right, as you can see, whenever I start my Deauth attack, it is struggling to maintain a connection with the router. In the process of multiple reconnection attempts, we have captured the handshake file, as you can see the capture01.cap file. But on cat, it's all encrypted. That won't be for long. Let's get our internet access back first. The earlier command nmon check kill stopped our network manager. We'll use systemctl start network manager to get our network access back. We'll connect to the Wi-Fi and open the browser. We need this to convert a cap file into a modern hash file which can be read by the hashcat tool, which we'll be using to run a dictionary attack on the hash. You can see we have downloaded a HC22000 file which looks like this, and we'll just change the name of that file to make it easier to remember later on. To run a dictionary attack, you'll need a large text file which you can download online, but we'll be using rocku.txt which comes inbuilt with Kali Linux. But before you follow the steps here, you need to remember to unzip the file, otherwise this won't work. In this command here, -m22000 just means more 22,000, and 22,000 is the specific hashcat in encryption. You see, once we run it, it immediately finds the hash. When I actually ran it for the first time, it took a couple seconds, but that was it. When I hit --show, it shows the hash and the corresponding password. And that is why it was so easy to crack. It was so small. Don't keep your password this small. But your ex may have kept a proper password. I have repeated the previous steps again, and I've got a proper password hash file. We can run hashcat on the file again and see how it performs. It doesn't seem to immediately give me the password. Even after waiting a couple seconds, it still seems to just keep running. Let's wait for a few more seconds. Okay, on checking the status, I'm getting Tuber Boy and the other boss as candidates, which is nowhere near the password which I've given for it to crack. Okay, couple more seconds. Okay, status now gives me Arjezi and Riverwash 9. Again, that's nowhere close to what I needed to crack. We might need to upgrade our attack from a Deauth attack to a evil twin attack. We will use Airgeddon to perform our evil twin attack. Airgeddon is an open source menu driven bash script which is used to run many wireless attack vectors such as Evil Twin, Captive Portal, Handshake Capture, DOS, and many more. It's a really good tool, but I found it to have certain issues, which is its heavy reliance on a specific hardware, which is a Wi-Fi adapter with VIF functionality, which is virtual interface functionality. This means the Wi-Fi adapter should be able to split itself into two logical modes, one hosting an access point and other performing a denial of service in monitor mode. In my experience, such adapters were really hard to come by. I could not find any of these adapters, but there are other alternatives and solutions to get this to work. This is through the plugin system of Airgeddon and a specific plugin which I found. Here I show the exact plugin path where the plugin has to be added, and this is the plugin multed.sh. This plugin will allow you to use two wireless interfaces instead of one with a VIF. Even if none of your wireless interfaces support VIF, both of them should have monitor mode. Okay, let's start up Airgeddon now. It's gonna take a bit to load in and it's gonna confirm that we have all the dependencies. Now it asks for an interface with access point master mode. We're gonna choose number 2, which is WLAN 1. Now an interface for Deauth or monitor mode, we're gonna choose number 3, which is WLAN 0. Now it presents us with a menu with all the wireless attack vectors. We want Evil Twin, we're gonna choose 7. Now from all the options of different types of Evil Twin attacks, we want the captive portal because we want to steal the password information from it. Now this will give us an error saying our card does not support VIF, but we have already covered that before and we have a plugin installed for it. Now we will need to scan. I'm saying a lot of nows, aren't I? We need to scan the wireless networks around us, looking for a device which is connected to an accessible router. We are looking for a device which is connected to a router. I found a router and it has clients. This is Nehanshu S24. We will run a Deauth MDK for attack on this router. This DOS pursuit mode requires a third interface card. We do not have that. Do I want to spoof my MAC address? Sure. Do I already have a captured handshake file? Yes, we do. In the beginning of this video, we have captured a handshake file. And do you remember the one which we cracked earlier? One we could not crack earlier? I'll be feeding that in. And also I'll be feeding in a password path where it will store the passwords or whatever the user enters. Here I select the language of the captive portal, and now I am just fiddling with my other device, getting it ready for the attack. And yep, the attack has started. Now you see the device here, it is connected to Snehanshu S24 FE. Suddenly is not able to connect to it and is just getting auto disconnected. And there is another access point with the same name. When the user tries to connect to it, he is redirected to this custom portal which asks for a password. If the user enters some random password, we will know it's not correct because we have the hash of the password from the handshake file. So we will just keep asking for the password again, which may probably will make it more trustable for the user, and the user might end up putting in their actual password, which we can again verify with the hash, at which point all our systems are going to shut down. The user will disconnect from this router and will auto connect back to the router they were always trying to connect to. being absolutely none the wiser about their passwords being stolen. Here we can just check the password file which I initialized earlier, and you can see we have captured the password and anything else they typed as well on failed attempts. You've just got pawned.